So in our previous class, we did fractions, and we said that a fraction is a part of a whole number or object. And then we looked at the different components of a fraction. We said that every fraction contains numerator, which is the number at the top, and denominator, which is the number at the bottom. We also said from our previous class, we said that there are different types of fractions. We have the proper fraction, where the numerator is smaller than the denominator. We also said we have improper fraction, where the numerator is larger than the denominator. And then we said we have mixed fraction, which is a whole number and a proper fraction. So we saw how to convert an improper fraction to a mixed fraction or mixed number, and then we saw how to convert from a mixed fraction or mixed number to an improper fraction. So you can get that video on my YouTube channel, Agbani Maths Academy on YouTube. So if you go to my YouTube channel, go to the playlist and locate the playlist on fraction. You'll see all the videos that I'm doing on fractions. There are other topics that I've also made videos on. So let's start. Today's class, we are looking at addition and subtraction of fractions, and then we'll also see multiplication and division of fractions. Okay. So whenever you come across a question on fractions, addition and subtraction of fractions, two situations occur. So two situations occur. So when adding and subtracting fractions, two situations occur. The first situation is the denominators are the same. The denominators of the fraction that you are adding or subtracting are the same. The second situation is the denominators of the fractions you're adding or subtracting are not the same. So the first situation, so whenever you are looking at a question on addition of fractions or subtraction of fractions, you have to check, are the denominators the same? The second is so the second situation you will encounter is when the denominators are not the same. So the way you go about solving these two situations, they are a little bit different, okay? So the way you go about solving when the denominators are the same is a little bit different from when the denominators are not the same. So let's go ahead to look at some examples. So let's look at the situation where the denominators are the same. For example, 1/5 plus 3/5. 1/5 plus 3/5. So in this particular situation, you look at the denominator here, the denominator is 5. You look at the denominator here, the denominator is 5. So we can clearly see that the denominators are the same. So what do we do in this situation? Since we know that the denominators are the same, all we need to do is pick out one of the two denominators. What we are trying to do is we want to make these two different fractions to become one. We want to make these two different fractions to become one. So two different fractions have two denominators. So we want to now pick out one denominator. So since the two denominators are the same, we can easily pick out 5 as the common denominator. So two denominators from two fractions have been made to become one denominator. They are the same, therefore the common denominator is 5. But if they are not the same, then we can try to explore something else. Okay? So, but they are the same in this particular example. So the denominator is 5. The next thing you are going to do is 5, the common denominator divided by each denominator multiplied by each numerator. The common denominator divided by each denominator multiplied by each numerator. So we're going to do 5 divided by 5, and that will give us 1. 1 multiplied by 1 will give us 1. Plus 5 divided by 5 will give us 1. 1 multiplied by the numerator 3 will give us 3. So that means our answer is 4 all over 5. So when the denominators are the same, it is easy to add them together. So when the denominators are the same, it is easy to add fractions together. So because you just pick out one of the two denominators and then add the two numerators. So even if you decide to just add the two numerators, they will be the same here. So the answer is very easy to solve, okay, when the two denominators are the same. Let's look at another example. So remember, we're looking at addition and subtraction of fractions. And we said that two situations occur. The first situation is when the denominators are the same. The second situation is when the denominators are different. Two whole number 1 over 8 minus 4 over 8. So we are going to apply what we have already learned before, because in our previous class we've learned about conversion of mixed fraction to improper fraction. So here we have a situation here which is a mixed fraction. So for us to continue solving, first thing we need to do is convert this mixed fraction to an improper fraction before we start solving. So what do? This is 8, the whole number is 2, and the numerator is 1. So we have learned about this earlier in our previous class. You can go to my YouTube channel to watch the entire class on converting improper fraction to mixed fraction and mixed fraction to improper fraction. So how do we go about that? 8 multiplied by 2 will give us 16, and 16 plus 1 will give us 17. So 2 whole number 1 over 8 is the same thing as 17 all over 8. So we have minus 4 all over 8. So in this case, we are subtracting. But just as we did in the first example, are the denominators the same? That's the first question. We can clearly see that the denominators are the same. So since the denominators are the same, all we need to do is pick out one of the two denominators to become our common denominator. So 8 is our common denominator. Next, we are going to do 8 divided by 8 gives us 1. 1 multiplied by 17 gives us 17. Minus, we come over to the second fraction. 8 divided by 8 gives us 1. 1 multiplied by 4 gives us 4. So now we have 17 minus 4 all over 8. 17 minus 4 is going to give us 13. So we have 13 all over 8. But whenever you have your answer as an improper fraction, it is better to convert it to a mixed number. Okay? It is better to convert it to a mixed number. So 13 all over 8 is, how many times can we have 8 in 13? The answer is 1. So we have 1. And then when you take out 8 from 13, what is going to be left? The answer is 5. So we have 5 all over 8. So we have also done this in our previous class, how to convert improper fraction to mixed fraction. The replay of that can be seen in my YouTube channel. Okay, so you can check it out in my YouTube channel. So we have been able to subtract this from this. But in the two examples we've considered, the denominators have been the same. Remember, we're considering addition and subtraction of fractions when the denominators are the same. Let's continue. So if we have 6 over 9 plus 5 over 9. So in this case, we can still see that the denominators are the same. So it is very simple. We bring out the common denominator of 9, and then we're going to do 9 divided by 9, 1. 1 multiplied by 6 is 6. plus 9 divided by 9, 1. 1 multiplied by 5 is 5. Okay? So what do we have next? 6 plus 5 is going to give us 11. So we have 11 all over 9. But this is still an improper fraction. This is an improper fraction. So we have to convert it to a mixed fraction or a mixed number. In one of my videos, somebody said there's nothing like mixed fraction. Yeah, some countries call it mixed fraction. Some people call it mixed number. Okay, so depends on where you are. So now this is 11 over 9. We have to convert it to a mixed fraction. So how many 9 do we have in 11? The answer is 1. We have 1. When you subtract 9 from 11, you are going to have 2 left over 9. Okay. So that means our final answer is 1 whole number, 2 all over 9. So we've considered the addition and subtraction of fractions when the denominators are the same. Now we are going to go to addition and subtraction of fractions when the denominators are different. Let's continue. Okay, now let's look at when the denominators are different. So we're looking at a situation where the denominators are not the same. Let's look at an example. So if I have 1 over 3 plus 1 over 2. 1 over 3 plus 1 over 2. Now we have a different situation. So the examples we've been solving earlier, the denominators have all been the same. But in this situation, the denominators are different. Here the denominator is 3. Here the denominator is 2. So what do we do? How do we get our common denominator? Because all we are trying to do is get our common denominator first. So to get our common denominator, in this particular situation, if you look at the two denominators, they are less than 10. So whenever you have two denominators that are different, but they are both less than 10, you can get the common denominator by multiplying the two denominators. So the easiest way to solve is by multiplying the two denominators whenever the two denominators are less than 10. So here, the common denominator will be 3 times 2, 6. So you apply this situation when the denominators are both less than 10. Yeah, you can find the LCM. If you find the LCM, you're also going to get 6. That's why I said, instead of finding the LCM, since they are both less than 10, the LCM will be 6. If the denominators are different and they are both less than 10, the LCM would be the same as when you multiply both of them. Okay? So now you have 6. So you do 6 divided by 3 gives you 2. 2 times 1 gives you 2. Plus 6 divided by 2 gives you 3. 3 times 1 gives you 3. So this will be 2 plus 3 gives you 5 all over 6. And that becomes your answer. So take note, in this particular situation, the denominators are both less than 10. So when the denominators are both less than 10, all you need to do is multiply the two denominators to get the common denominator. Let's look at another question. So here we have 4 over 6 plus 3 over 5. In this situation, the two denominators are different also. And also, the two denominators are less than 10. So just as I said earlier, when the two denominators are less than 10, all you need to do is multiply the two denominators to get the common denominator. And that will be 30. So the next thing you're going to do is 30 divided by 6, that will give you 5. 5 times 4, that will give you 20. plus 30 divided by 5, that will give you 6. 6 times 3, that will give you 18. And then we have 20 plus 18, that will give you 38. 38 over 30. How do you get 30? Yeah, I said when the common denominator, you are trying to make these two fractions to become 1. So here the denominator is 6, here the denominator is 5. So to get 30, the common denominator, you multiply both denominators. So 6 multiplied by 5 gives you 30. This is when the two denominators are less than 10. So now you have 38 all over 30. What can divide both 38 and 30? The answer is 2. So 38 divided by 30, this will give you 19. 38 divided by 2 will give you 19. 30 divided by 2 is going to give you 15. So, but this is an improper fraction. Therefore, we have to convert it to a mixed fraction. So how many 15 do we have in 19? The answer is 1. And then when you remove 15 from 19, you're going to have 4 left over 15. So that becomes the final answer. So now we've seen a situation where the two denominators are different. That's 1. We've also seen that these two denominators that are different, they are both less than 10. Now we are going to see another situation that will arise when the two denominators are different. Okay. So let's say we have 2 all over 5 plus 7 all over 10. 2 all over 5 plus 7 all over 10. We can see that in this situation, the denominators are also different. We can see that the denominators are also different. But unlike the first one, where we had 2 and 3 as one of the examples, here 5 and 9, we can see that, 5 and 10, we can see that 10 is a multiple of 5. 5 times 2 will give you 10. So if you have two denominators where one of the two denominators is a multiple of the other denominator, if you have two denominators where one of the two denominators is a multiple of the other denominator, instead of finding the LCM, once you see two denominators where one of the denominators is a multiple of the other denominator, what I mean is that 5 is going to multiply something to give you this one. So once there is a relationship like that, all you need to do is pick this one as a common denominator. So 10 is our common denominator. So if you have a situation where you have 4 and 8, if you have a situation where you have 4 and 8, 8 is going to be the common denominator because 4 times 2 is going to give you 8. If you have a situation where you have 3 and 9, 3 and 9, you can use 9 as your common denominator because 3 times 3 will give you 9. So when the smaller one can multiply to give you the bigger one, use the bigger one as your common denominator. Okay, so now we have 10. So 10 divided by 5 is going to give you 2. 2 times 2 is going to give you 4. Plus 10 divided by 10 is going to give you 1. 1 times 7 is going to give you 7. So at this point, you have 4 plus 7. That will give us 11. So we have 11 all over 10. So we still have an improper fraction. So we have to convert it to a mixed fraction. So how many 10 do we have in 11? The answer is 1. When you subtract 10 from 11, you're going to have 1 left divided by 10. So now we've seen two situations when the denominators are different. The first situation is both denominators are different and they are less than 10. This one we just looked at, the denominators are different, but one denominator is a multiple of the other denominator. So in this case, we can see that we can use the bigger one as the common denominator. Okay, let's look at another example. So we have 3 over 4 minus 4 over 12. 3 over 4 minus 4 over 12. So what will be the common denominator? 12 will be the common denominator, correct? 12 is the common denominator because 4 will multiply itself. 4 times 3 will give you 12. So since 12 is a multiple of 4, then we simply use 12. So now we're going to have 12 divided by 4, 3. 3 times 3, 9. I was already thinking about the final answer. Minus 12 divided by 12, 1. 1 times 4, 4. So now we have 9 minus 4, and that gives us 5 over 12. That becomes our final answer. So we have seen a situation where both denominators are less than 10. We've also seen a situation where one denominator is a multiple of the other denominator. So now we are going to see a situation where both denominators are more than 10. So in this situation, we have 15 over 12 minus 8 over 15. So in this particular situation, the denominators are different, correct? Second, both denominators are more than 10. Now, if you decide to multiply the two denominators, the number you are going to get is going to be a very large number. So I will not advise that you multiply the two denominators since they are more than 10. But it will be better for you to find the LCM of both denominators. Okay, so let's find the LCM. Though I'm going to make another video, another tutorial where we are going to focus on LCM and HCF. But let's quickly do it. So we have 12 and we have 15. So look for a number, the smallest number that can divide at least one of the two. So 2, we have 6 and then 15. 2 can still divide 6, so we have 2, we have 3 and 15. So 2 can no longer divide any of the two numbers. So we go to 3, we have 1 and 5. And we go to 5, we have 1 and 1. Okay. So this means 2 times 2, 4. 4 times 3, 12. 12 times 5, 60. But if you decide to multiply the two, the common denominator of the two denominators is going to be 60. If you decide to multiply the two denominators, you are going to get a large number, which is 180. It will make our work a little bit complex. So using LCM when the two denominators are more than 10 makes your work easier. If you multiply them, you will get the same, and you solve correctly, you will get the same answer. But it will just make your work more complex. Okay. So we found out that the common denominator is 60. So now we can simply do 60 divided by 12. That will give you 5. 5 times 15. What would that be? 5 times 15. I think that would be 75. So somebody should confirm that. 5 times 15, 75. Okay, so now we have 60 divided by 15. That will be 4. 4 times 8, that will be 32. So next, we're going to do 75 minus 32. 75 minus 32 is going to give us 43 all over 6. So now we have looked at addition and subtraction of fractions. We've seen how to add fractions when the denominators are the same. We've seen how to add fractions when the denominators are different. Okay. So next thing we are going to look at is multiplication and division of fractions. Multiplication and division of fractions. So before we go over to that, I'd like you guys to solve this classwork and give me the answers in the comment section. Let's try to get that done in 10 minutes time. Yes, good work. Good work. Okay, let's continue. Multiplication and division of fractions. We're just going to go straight to examples. So we have looked at this in our previous class. we've seen how to reduce fraction to its simplest form. Okay? We've seen how to reduce fraction to its simplest form. So when you are multiplying fractions, what you need to do is multiply the numerators together, multiply the denominators together, and then reduce the resultant fraction to its simplest form. Let's see an example. Two all over 5 times 3 all over 6. So this question is very simple. So we can follow these steps. If the question is a little bit more complex, then what we are going to do is, when you have a simple question like this, when you are multiplying two simple fractions, what you can do is you multiply the numerators and denominators together before you reduce the fraction to its simplest form. But if you have a more complex fractions that you are multiplying, then you can do this first before you multiply the numerators and the denominators. So, okay, thank you. So there are two ways of doing it. If the fraction is very simple, you can just multiply the numerators, multiply the denominators, and reduce the fraction. But if the fraction is a little bit complex, then you have to reduce it first before you multiply. So in this case, you can just go ahead to multiply. 2 times 3 gives you 6 all over 5 times 6 gives you 30. So now you have 6 all over 30. But you can still break this down. Remember, then reduce the fraction to its simplest form. Reducing the fraction to its simplest form simply means look for a number that will divide both numerator and denominator and use that number to divide both numerator and denominator. So if you look at 6 all over 30, 6 can divide 6 and 6 can divide 30. So we'll use it to break it down. So 6 divided by 6 gives us 1 and 30 divided by 6 gives us 5. So our answer is 1 all over 5. Very simple. Guys, please, can we take this live to at least 10,000 likes? Okay, so we have 1 over 5 as our answer. Let's look at another example. Okay, so in this situation, if we decide to follow this step, we are going to have large numbers that we need to break down. So what we can do here is first break down before you multiply. So in this situation where the numbers look a little bit complex, you first break the numbers down before you multiply numerator and denominator. So what do I mean by that? You look at numerator and denominator and check if there is a number that can divide the numerators and denominator. So you can check up and down. You can check up and down. That means up and down, or you can check diagonally like this. So that means you can look at these two to see if there is a number that can break them down. You can look at these two to see if there's a number that can break them down. You can also look this way, this and this, if there's a number that can break them down. And you can also look this way to see, you can also look this way to see if there's a number that can break them down. Right? So you can go this way, 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 but you cannot break down the numbers along the horizontal path. You cannot break them down along the horizontal path. Okay? So let's look at that. If we consider 8 and 12, is there a number that can divide both 8 and 12? The answer is yes. The number that can divide 8 and 12 is 4. So 8 divided by 4 will give you 2. 12 divided by 4 will give you 3. So now we have, instead of having 8 over 12, we have 2 all over 3 times 15 and 20. Is there a number that can divide both 15 and 20? The answer is yes. 5 can divide both 15 and 20. 15 divided by 5, 3. 20 divided by 5, 4. So you have 3 all over 4. So in this situation, we have reduced the fraction first before we can multiply numerator and denominator. We can go further to reduce it again because we can go this way. 2 and 4. 2 can divide, right? So this will give us, but let's not bother about that. 2 times 3 gives us 6 all over. 3 times 4 gives us 12. So we have 6 all over 12. But 6 all over 12, 6 can divide both 6 and 12. So if 6 divide both 6 and 12, 6 divided by 6, 1. 6 divided by 12, 2. So our final answer is 1 over 2. You can watch more of my videos on my YouTube channel, Agbanimas Academy on YouTube. Subscribe, turn on the bell notification, and watch my videos, please. What I do over there is all my live classes, I post the replay of the entire live class, though I edit some parts. So you can watch my videos on YouTube. You can also send the links to students who need to learn about these topics. If you're a parent also, you can share it with your students, your children, for them to watch and learn. If you go through my playlist on fractions, there'll be nothing about fractions that you will not know about. If you go through my playlist on simultaneous equations, there'll be nothing about simultaneous equations that you will not know about. So my YouTube channel is actually a library of maths tutorial videos. So just go to the playlist. The playlist section is where you see all the topics that you can learn. Okay, so we've seen how to multiply fractions. Now we're going to look at how to divide fractions. So when dividing fractions, you have to convert the division sign to multiplication and then write the inverse of the second fraction, and then write the inverse of the second fraction. So what do we mean by inverse here? So if I have 2 all over 3, the inverse of that is 3 all over 2. So I flip it, I turn it upside down. So that's inverse. So when I'm dividing fractions, I convert the division sign to multiplication sign. And when I do that, I flip the second fraction. I turn it upside down. Let's see why you have to do that. If I ask you, 4 divided by 2, 4 divided by 2, what's the answer to 4 divided by 2? Can anybody tell me the answer to 4 divided by 2? 2, correct. 4 divided by 2 is going to give us 2. So now let's use this process to confirm that this is correct. So 4 divided by 2, we have 4 over 1, because every whole number has an invisible divided by 1. So 4 is written as 4 over 1 divided by 2 over 1. Right? 4 divided by 2 is 4 over 1 divided by 2 over 1. But now let's follow this process. If you turn this to multiplication, you're going to have 4 over 1 times 1 over 2. So we are just following this process now. We are applying this process to confirm 4 divided by 2 is equal to 2. So just as we did in multiplication, you multiply the numerators, multiply the denominators. 4 multiplied by 1 is equal to 4. 1 multiplied by 2 is equal to 2. So 4 divided by 2 is 2. By following this process, not just by writing a division sign, by following this process, right? It might look as if I'm just repeating the same thing. If you try it with, let's say, 10 divided by 2 or 10 divided by 5. So if you follow this process, you're going to confirm that this is the correct answer. Okay. So I'm just trying to show you why you should use this to convert the division sign to multiplication and write the inverse of the second fraction. So let's look at some examples. Twelve over 10 divided by 4 over 5. So the first thing we have to do is convert the division sign to multiplication. So we have 12 over 10 times, then you flip the second fraction, 5 over 4. So we can easily break this down. 5 can divide both 5 and 10. So 5 divided by 5, 1. 10 divided by 5, 2. 4 can divide both 4 and 12. So 4 divided by 4, 1. 4 divided by 12, 3. So now we have 3 times 1, 3. All over 2 times 1, 2. So we can see that this is an improper fraction, which we can convert to a mixed fraction or a mixed number. So that gives us 1 whole number, 1 over 2. Let me do one more example for, for division before we go. Okay, so let's look at this situation. 28 divided by 30 divided by 40 divided by 28 over 30 divided by 40 over 18. So just as we did in the previous example, the first thing we do is convert the division sign to multiplication and then flip the second fraction. 28 over 30 times 18 over 40. So next, we look at numerator, denominator to see if there are any numbers that we can cancel out. If you look over here, 6 can divide 30, 6 can divide 18. So 18 divided by 6 gives us 3. 30 divided by 6 gives us 5. Let's check if we have another place to cancel out. 28 and 40, 4 can cancel out. 28 divided by 4 gives you 7. 40 divided by 4 gives you 10. So what we are going to have is 7 times 3, 21, all over 5 times 10 gives you 50. Okay, so thank you so much. So this is these are the simple ways of adding fractions, subtracting fractions, multiplying fractions, and dividing fractions. Please subscribe to my YouTube channel, watch my videos till the end. I'll be glad if you do that. Watch my videos to the end and learn. And also, don't forget to like the videos and share with your friends. So thank you so much. Hope to see you tomorrow in my next live class. Good night. Good night. Born 7. Good night. Have a wonderful evening. Adios.